In the last video, we had mentioned that we're going to be setting up a display system within the game that will allow us to give readouts for the number of nodes currently in the game and the amount of health that each player currently has. In this video, we are going to put that display together. The display that I'm talking about is a few lines of text which will be drawn out to the screen. In order to accomplish this, we'll need a sprite font that can be used in conjunction with the sprite batch's drawstring method. So over the course of this video, we'll set up a sprite font, and then we'll set up the necessary lines to draw out what I'm going to call a very rudimentary HUD.
Yeah, and there's no reason to whiteboard this for the simple fact that everything Logan's about to do has been seen before in the XNA 101 class. The bottom line is we're just going to set up a sprite font and do some string drawing.
So, well, let's jump in and get started. First thing that we'll need is the sprite font asset itself, and I'll add that to the content subproject. We'll add in a new item. This item will be a sprite font. We'll name it Tahoma, just so that it automatically picks up on the Tahoma font. And here we have our sprite font loaded up. I'll simply close that out because I'm going to leave all of its parameters default. Now we can turn our attention to the game class, game1, and make a field within our game class to hold the sprite font. So down here, right after sprite batch is defined, we'll make a field of type sprite font, and we'll simply call this field font. Now to load in the asset, we'll jump down to load content right above our call to the sprite sheet loading, and we'll set our font equal to content.load, where we'll load in a type of sprite font, and the asset name will be Tahoma. Now that our sprite font is set up and ready for use, we can turn all of our attention over to draw. I'm going to draw all of the text to the screen after nodes are drawn, so that if a enemy or a ship goes up in the corner of the screen where all the text appears, the text will actually draw over and on top of any of the sprites. So to begin with, the first piece of information that we're going to display is the number of nodes currently in the game. So we'll take a look at our sprite batch. We'll tell it to draw a string, and we're going to feed over our font for the sprite font parameter. The text that we're going to draw is a piece of formatted text. So I'll drop in the call to string.format. I'll leave it empty just for the time being so that I can finish off the call to drawstring. Then we'll turn our attention back to exactly what is going to be formatted and drawn. Because the next thing I want to address is the position at which this text will be drawn on screen. I'll specify this using a new vector2 and provide an offset of 10 by 10. So we're 10 pixels off the top left corner of the screen. One final parameter we need to feed in is the color, and I'm going to give a color of orange. Now that we have the call to drawstring in place, now I'm going to address the information I would like shown. The string is going to say nodes and then draw whatever is in parameter, or excuse me, argument 0. Then we'll specify that argument as node.nodes.count.
Basically a count from our static nodes list.
Exactly, the original nodes list all the way back to node that contains all nodes currently in the game. And with this one call, we should be ready to build, get our asset put together, and all of the code rebuilt. And now if we run the game, we can see that we begin with 9 nodes. If I slam into an asteroid, we now have 8 nodes. If we destroy our player and an asteroid, we're down to 3.
And not only that, we can watch the numbers diminish as they go off screen.
So at this point we can now prove that as enemies go off screen, they do in fact get removed. So that means our remove off screen method is operating correctly.
Cool.
Now there's another piece of information which is very useful, even right here as we're working with things like the player's health and the enemy's health, and that would be a health readout for each of our players. This will be a little bit more interesting because the way we'll set it up is we'll have a loop that will go through all of the players in the player's array, and then it'll look at each element in that player's array. And if that specific player has a ship, we'll draw the ship's health. If that player does not have a ship, if that player's ship is null, we'll simply draw empty brackets to indicate that no ship is filling that slot. So we'll begin our for loop. And I'll set a for loop to use an index variable, and the reason I want that variable is just so that as we're going player by player, I'll actually have a number to put next to the letter. So we'll have like maybe P1, P2, P3, and P4 to indicate which player we're looking at. and the loop is going to go through up until the overall length of players. So we'll look into player.players.length to get the amount that we should be looking for as a total. Now, for each iteration of the loop, I am going to make a ship variable, and that gives ourselves an easier handle when we look into ship health. So I'm going to make a player ship local variable called ship, and that will be set to the specific player that we're looking at. We'll look at player.players sub I.ship. So I actually retrieve the ship value out of the current player. We're also going to drop down a local variable of type string called text. The idea here is that way I can focus on the string formatting before we worry about the call to spritebatch.drawString. Now the next thing that we need to do is a check. And this check is the current ship in existence or is it null? So we'll do a check and see if ship is not equal to null, then we have a ship and we should be drawing its health. So we'll jump in here and we'll set text equal to the string formatted value of, and the display string is going to be the letter P, and then I'll specify element or argument 0 in curly braces, and we'll say that that element's health is equal to argument 1. And then we'll specify 2 arguments. The first one will be the numerical value for each player. Now, since the loop goes 0 through 3, we'll offset this by 1. We'll take that index variable and add 1 to it. And then the second argument is going to be the health of that specific ship. So we can simply drop in ship.health. And that wraps up the call to string format, and that value will be stored in text. Now, if the ship was null, we'll drop in an else clause to handle that case. If there is no ship, we'll still draw what player it is, but we'll simply draw empty brackets to indicate no ship. So we'll use another formatted string, this time showing, well, once again, player element 0, so whichever player we're looking at, and then a simple open closing less than sign to indicate no ship. In this case, we only need one argument to fill in which index we're looking at, which is once again I plus 1. So that wraps off the call to string format. We can end off this statement and then move down. At this point, we should have text either initialized with player health or text initialized with an empty player slot. Now that we have text set up, we can use it to draw the string out to the screen. So we'll make a call to spritebatch.drawString, feed in the current font, feed in the given text, set a position. Now the position is a little bit interesting because as we go through player by player, we would like our text display to look like it's advancing line by line. And in order to accomplish that, I'll multiply our current player index against 20 to make sure that we move down 20 pixels every time we move to a new line. So I'll specify a new vector 2 for positioning. X is easy enough because it's going to be the same 10 pixel offset. Y is going to be the index variable times 20 to move down 20 per line, but we've also got to keep in mind that we, before all the players, already have a line of text, and that comes from the original node count. So I'm going to specify an additional offset of 50 pixels. So say give 20 to move down to the line before, and then maybe another 10 for a line and a half, or half a line after that. So that should wrap up our positioning. Now we can specify the color to be used, and we'll use the same orange color. And with all of that put into place, we should be able to build and run, and we now have 4 player slots. The first one is occupied by a player ship. If we hit an asteroid, our health drops to 50, and if we hit another asteroid, we get destroyed and our slot drops out to nothing. We can spawn another ship in. If I hit enter for player 1, we get a ship back, and if I hit start for player 2, we get a second ship. So now we can see we have 2 players and their respective health. We're out of asteroids, so we can't damage the ships, but we can see that the ship display is showing all of our healths for different players.
Go ahead and restart. Let's bring 2 players in from the very beginning.
Alright, so running player 2, and here we go. So
Ooh,
first player
down to 50.
Down to 50 as well, and dead.
And survived. All right, fine.
And while we're playing with dying, let's go back to the scenario that we originally created player to accomplish, and that would be what would happen if player 1 dies and player 2 remains.
Okay.
Can player 2 remain or retain their ship? So I've spawned in. I'm yellow ship. There's red ship. Red ship is down to 50 and dead, and I still have control of player 2.
Very
so
nice.
Player 1 exists in its own slot, independent of player 2.
Outstanding.
And with that, that takes care of the information that I wanted to get displayed. Once again, this is simply useful information to have. The node count is good to keep track of so that as you're watching objects that should be dying as they go off screen, making sure that you never have any additional objects that you can't see. And the player health is very useful for diagnosing or tweaking your game balance as you decide how damaging things should be and how strong the ship could be.
All right. And with that, anything else you want to add?
Nope. That covers it.
Well, that's going to wrap up this video. Thanks a lot.